I've only got 2 people on me, but this is all the time.
Move to the start.
I'll start by getting the
Thank you.
So we'll get started in about 1 minute.
Okay, thank you, folks. This is the SFC working group, as long as I don't bump my laptop too many times. Welcome. This is the Note Well. You should be very familiar with it, but just in case, there are rules. You've agreed to follow them, mostly about making your work available to the IETF to build upon and disclosing IPR, but there are more details. Read the Note Well, read the things it points to. Please, it does matter. I know it feels like noise. It matters. So we have the agenda. If there's things that need to be changed, let us know. We have some flexibility. We have 3 presentations lined up. One on service function chaining in the fog RAN. Actually, it's 4 presentations because 2 on context allocation, 1 for timestamp and 1 for broadband allocation. 1 on an independent control plane, an approach to control plane implementation that the developer asked to present. And then we expect to spend a significant amount of time on topics you guys want to discuss. What do you think is important about where the work is going and so forth? So that translates to this detailed agenda. Before going to that, I do want to say we're working on getting the NSH document done. I was trying to talk with Uri, but I didn't catch up with him. Uri and Paul are trying to get all the comments. We've agreed. There are a few issues which have been discussed on the working group mailing list and the chairs have to call consensus on. And we will be doing that in the very near future. We are nearly done with that document, I believe, but we need to make it move forward. We're also working on how to move forward the OAM documents and the TLV documents as discussed at the interim and discussed on the mailing list. And then we can adopt some of the MD1 documents and additional MD2 documents also as discussed. So we're trying to move the work forward with a focus on the deliverables we have in front of us. So this is the agenda. Does anybody wish to make any changes to the agenda? Okay. And that's probably my last slide. Yes. So next one is FOGRAN. And just let me know when to move it forward. The intent is about 10 minutes for the presentation and then questions, comments, discussion. We want to make sure, no point in scheduling a presentation if we don't give you guys time to actually ask questions.
Exactly. Thanks. So my name is Carlos Bernardos. I'm from University Carlos III in Madrid, and I'm presenting this work on behalf of my co-authors and myself, Alain and Akbar. So the motivation for this document, well, the initial motivation came from virtualization. So this is very much virtualization-oriented work. So we know that virtualization is everywhere now. And one of the places where virtualization is becoming more important is on the radio access networking side. So initially, there were some approaches in which some of the functionality of the RAN was centralized, and this basically was the trigger for the so-called Cloud RAN stuff. And then not only centralizing the functionality in a given point provided advantages, but also trying to really virtualize several functions or different functions and being able to move them around. So not only in a central point where running everything virtual, centralized provides some advantages, but also being able to, depending on the actual scenario, being able to run certain, not all of them, but some of them in a virtual environment that you can more flexibly manage. Next, please. And then in addition to this virtualization, we have also the tendency that there is a requirement for having more computing power at the edge of the network. In the future 5G, there will be, or it's likely that there will be many applications that will require extremely low delay latency, and those will be very challenging to be achieved by having a very centralized architecture. So it's therefore required to be able to put some functionality close to where the users are. And this has led to what is called by some people as intelligent edge. And this basically the main area where, for example, the HC MEC, Mobile Edge Computing ISG, is currently working on. Next, please. And in this need for having computing power at the edge, virtualization is also very important because network functions can benefit from lower latency by having functionality opportunistically run at the edge. So there may be several scenarios or several examples. For example, we can have a local breakout, depending on the situation, being triggered at the edge, and that will allow to save some bandwidth in several scenarios. We can also have, and this is something that the MEC is looking at, additional benefits from using information, context information that is available at the RAN, and making use of that information for applications or for the network functions themselves. Sorry. Next, please. And this virtualization and this edge computing powers leads us to the next, which is the definition of what we mean by FOGRAN. Well, first, the edge virtualization computing capabilities at the beginning were assumed to be pretty much static. So you have some computing power at the edge that is fixed and doesn't move and is on the infrastructure side. But we can go a step beyond that, and we can assume that the computing power, the capabilities, the infrastructure can be mobile, can be deployed in mobile platforms, and can even reach the end device, the end user device. And all this set of capabilities that are not really not centralized, but not even in the infrastructure side at the edge, is what we call the fog. So basically, all these computing resources. And when we use those computing resources to run functions from the RAN to benefit from that lower latency and those capabilities, this is what we call, or we refer to, the fog run. So that's basically the scenario we have in mind. Next, please. And this is basically try to be depicted in this picture. So we have the infrastructure side, so the base stations, say node Bs. We may have what we call local processing units, but basically computation resources at the vehicles, at the network infrastructure access, at different sites. And then we have the connection with the core and the central data centers on the right-hand side of the figure. And we can run virtual network functions anywhere there between the fog and even in the central cloud infrastructure. Next, please. Here is, oops, well, that shouldn't look like that, but anyway, there's a figure that is in the draft that basically tries to depict that we may have different heterogeneous computing resources at the fog. Like you may have a UE, you may have a card, you may have a node B, you may have some local resources in a local data center, and there on top of that you can run control plane and data plane functions in different places, and those resources may even belong to different stakeholders. So this fog is really heterogeneous in nature. Next, please. So what is the applicability of SFC to this environment, this scenario? Well, there are already some documents that have been discussed in the working group relating or describing how the SFC can be applied to mobile networks. So we have the working group draft on use case mobility, and then there is also an individual submission that is looking more into brand-related aspects. But this is really something that is in scope. And here in our document, we try to basically look at this from the fog run perspective. Next, please. So in this case, we can benefit from this by having VNFs, virtual network functions, that are basically bandwidth and latency constrained, benefiting from running at the fog, because that is where you can have lower latencies. And then additionally, we may, as I mentioned before, benefit also for using information that is available at the run, context information, mobility information, signal-related location information for the functions that are running on top of that run themselves. And this may be used, for example, to facilitate the convergence of multiple radio access technologies, because you can virtualize several functions of those technologies in a data center, and you may benefit from using the information from the different routes to provide a better convergence. Next, please. Here we are using the same picture that we used before, but trying to basically depict these virtual network functions and applications that are on top of the figure, that then are chained, that are running on different physical resources, well, virtualized resources running on top of physical resources at the fog and even at the central cloud environment. And for that, we need to chain those functions. So we have resources that belong to different stakeholders, different administrations. They're very heterogeneous in nature, or maybe very heterogeneous in nature. And you want to run functions on top of them and chain those functions to get a given function, given service, given application. And for that, we believe that SFC is a key component that we need to ensure that provides the features that we require for fog run applications. Next, please. And then in the draft, basically, we describe this scenario, and we also try to initially identify some requirements, some early requirements for what we believe SFC needs to provide to meet the requirements for fog run. There are some listed there. The point here is not really to list all the requirements, but just to mention that we are identifying in the draft kind of requirements that are triggered by this fog run scenario.
So
yeah.
Now I'm going to pretend I can wear a participant hat for a moment.
Yeah.
A lot of these requirements look like they're deployment requirements, not protocol requirements or control plane requirements. But if you use SFC to do this, you have to make sure you do these kinds of things. Like, well, if you're going to meet a low latency budget, you have to put things in the right places. Are there requirements in there that affect the data plane mechanisms we're establishing, or the control plane mechanisms we're going to establish? Or is this about how you would use, there are requirements if you want to use SFC to address the FOGRAN case?
We have in mind both in the draft. It's true that the initial draft is mainly deployment. Those are the ones that are in the draft, but there are others. For example, these heterogeneous administrative domains that we need to cross and chain. That imposes additional requirements. The control plane, here we have that even the UE may be involved in the chaining, so that may impose additional requirements on the control plane mechanisms. So there are more that we have in mind. This is just initial version that we wanted to collect feedback, but there are both deployment and protocol requirements. And next one. So basically, our goal is to collect more feedback from the working group and also to make the community aware that we are working on this. This is actually something that we are going to evolve, or we are going to work more in a project that is starting in June this year. It's actually a European Taiwanese project that is called 5G Coral. So we hope to be able to contribute with more requirements and actual implementation and architecture suggestions to the working group. And one question we have is whether you think this is interesting to keep on working, and whether, for example, you think that it would be good to maybe team up with the guys on the use cases, mobile use cases draft. So that's all from my side. Questions?
Yeah, and maybe
Yeah, can you?
Uri to Intel. Was wondering if you could shed some light on the kind of top to bottom stack that you envision, either in this context of this project or more generally. One of the, I think, when I look back at the work that we are doing in this work group, while it's really nice to meet friends for 3 years, we were working bottom up, and we are doing lots of work on the data plane, and exactly how something like FOGRAN could be able to use this has to do with a little bit more complete solution than just the data plane work that we are doing. There's other aspects like interoperability between different service functions. So what are your thoughts on these areas?
Okay, so that's a very good question. I mean, so far the project is not even started, so it's more, we don't have a clear picture yet on the solution. Probably by next IETF we will have, because that will be, well, by next, maybe not even there, but by Singapore we will have. So we are very open. We are exploring like SFC, IETF SFC work. We are also looking into what the SC is doing, segment routing, so many different solutions that we are thinking that could be applied. So we don't have a solution. So this is really use case, and this is what we want to do, but we don't have a clear solution in mind. So we are exploring.
So, and the other question, any requirements you have for what kind of information exchange between service functions?
One thing that we want to benefit is, as I mentioned, in the project is key to be able to use the context information from the run itself, and not only for the actual end application, but we believe that that can be also useful for the chaining itself. So, for example, the load of the signal quality or the coverage of the run, that kind of thing may affect the way you chain. The way you change function, because you may have different available, and depending on the location, depending on the situation. So this kind of information we think should be considered. But again,
yeah,
we are very
it would be, when you guys get to it, it would be nice to get that a little bit as a request for requirements.
Any more questions? Well, moving on. Thank you, Carl.
Thank you.
Fortunately, Carl Mizrahi has taken a minute. Fortunately, John Strassner has agreed to back him up. So this time is particularly important because our primary minute taker is the next presenter. Oh, sorry, that was foolish. Yeah, Tal Mizrahi is our next presenter. He's also, I wanted to make a point of thanking him because he's taking minutes, as is John Strassner. So John is taking particular minutes this time because Tal is presenting.
Okay, thanks. My name is Tal Mizrahi. I'm from Marvell. And this draft is joint work with Ilan Yerushalmi, David Melman, and Rory Braun. Next, please. Okay, so this draft is about using a timestamp in an NSH metadata And in a nutshell, the idea is that when a packet goes into the SFC domain, it has an NSH header attached to it. Part of that NSH header can be an MD type 1 metadata, which includes the timestamp. And now all the SFs and SFFs that receive the packet with the NSH can use the timestamp for various purposes. Next, please. Okay, a few words about this draft versus another draft, which is called KPI stamping. So KPI stands for Key Performance Indicators. And this draft has been around for over a year now, I think. It talks about how service functions can use metadata type 2 to incorporate various types of information which are related to quality of service. So for example, it has some quality of service fields, including timestamps. And some of the feedbacks we received about the KPI stamping draft was, first of all, you're using MD type 2 and that's not mandatory, so some vendors will not implement that. That was one comment. And another comment was you're incorporating information which is on a per SF basis. And that may be a lot of information, and again, some operators will not want to use so much overhead in all the packets. So this is the background for why we wanted to write this draft, and basically the idea is to be able to insert a timestamp into the NSH metadata type 1, which is mandatory, and to be able to use that routinely in all the packets. And when a problem is detected, you can either use KPI stamping or you can use IOAM in other scenarios to do further analysis and find out what the problem is and how to resolve it. Next, please.
Before I go on to the next slide, just
Sure.
again, as a participant, I want to encourage people to ask questions. So my obvious question is, a lot of the MD1 encodings use all 16 of their bytes. So there can't be a variation on that MD1 encoding that has your timestamp. Have you talked to the other guys doing MD1s? Because an MD1 is a fixed, well-defined set of encodings. So there can be an MD1 definition which includes a timestamp field, but what about the ones that can't fit it?
Right, so we're certainly open to discussion, and there's certainly maybe a mix and match here where you can mix the timestamp with some other fields from other allocations, and it's certainly something to think about. We'll be happy to hear more comments about it.
Because I had the same reaction to the security draft. Well, you can't like just arbitrarily combine TLVs in an MD1, because an MD1 is a specific well-defined allocation.
Right, yeah, well, it is what it is.
Name and
Greg.
affiliation.
Yes,
please.
Greg Mirsky, ZTE. So can you recapture the purpose of the timestamping? So
Yes.
are you trying to measure residence time?
So bear with me 10 more minutes, and if I don't answer this question, I'll get back to you, okay? Maybe even 5 minutes. Okay, so this is the structure of the allocation that is proposed in the current draft. We start from the bottom, so we have 64 bits of the timestamp, and this is a 64-bit field which is based on the IEEE 1588 timestamp format. And one of the reasons here was to allow existing implementations which already rely on IEEE 1588 to synchronize time to be able to use the same timestamp format using the same clock. So in addition to that field, there's also a source identifier, a source interface, which indicates which interface the packet was received through in the classifier. And there's also a sequence number, which can be used for detecting out-of-order delivery or detecting duplicate packets. It can help in detecting loops in some cases. Next slide, please. Okay, so let's talk a bit about use cases, and I think this goes back to Greg's question. So we're going to look at a few use cases, and I'm sure people here can think of other use cases. The first one is the very basic one, delay measurement. Okay, so the idea, if we have the timestamp attached to the packet by the classifier, this is T1 in this case, Then the packet reaches one of the SFs. The SF captures when the packet was received, T2. And if the nodes are synchronized in the network, this allows one-way delay measurement, T2 minus T1. So that's a very basic example of how nodes along the way, SFs or SFFs, can know the one-way delay. Another possible use case relates to something called alternate marking. So in a nutshell, alternate marking is a way for performance monitoring. It can allow very accurate performance monitoring so that we split data packets into blocks of consecutive packets. Each block is assigned a color. So we see here the color is 0 and 1 intermittently. And the assumption in alternate marking is that there is a field in the header which is used for the color. So as a side note, we'd like for NSH to be able to support that bit to be able to do alternate marking. Right now, it's not supported in the NSH base header. But if you're using the timestamp allocation, next slide, please. You can actually take one of the bits in the timestamp, any bit you decide. You can take one bit in the timestamp, and that's your color bit. Okay, because by nature, this bit changes its value periodically. And this can be used as the bit for alternate marking. So if we don't have that color bit in the header, we can use the timestamp for that. It's kind of a workaround, but it can work. Next, please. Another use case which can be considered is consistent updates. Let's say that we have a service function chain, and we have two service functions, SF1 and SF2. And let's say that we have a policy which affects both SFs, policy A. And then we want to update the network to work with policy B, again, which affects the two SFs. And we want to do this update in a consistent way. And when I say consistent, I mean that every packet should be forwarded either according to policy A or according to policy B, but not according to a mixture of the two. So one way we could consider of doing that is to use time as a basis for deciding when to do that. Next, please. So for example, we can decide we update at time t0, and then before time t0, we use policy A. After time t0, we use policy B. The problem with that is that even if we have perfect synchronization, we still can't guarantee consistency, because packets that are in the middle between SF1 and SF2 at time t0 will not be handled consistently. So what can we do to address that? Next slide, please. Can use the timestamp. Okay, so if the timestamp value is less than t0, policy A. If it's greater or equal to t0, we use policy B. That guarantees consistent handling. So that's another use case. Next slide, please. Okay, so this draft was first submitted a couple of months ago, and basically it defines the format of the MD type 1 timestamp allocation, and it discusses some of the use cases we talked about now. And I believe, you know, some people may agree with some of the use cases and may disagree with other use cases. I'm not sure we need to agree on all the use cases. That's not really the main part of this draft. I believe that mainly we're interested in feedback about whether it's useful to have a timestamp in the MD type 1 allocations, in one of the MD type 1 allocations, and whether people think there are other use cases this may be useful for. That's the main feedback that we're looking for at this point. Thanks. So this would be a good time for comments.
Okay. Again, Greg Mirsky, Eric. ZT. Okay. First comment, and I think that we talked about it. I would recommend consider to support NTP timestamp format as well. Yes, if you're taking their clock off your hardware, where you more likely running 1588 synchronization, so you synchronize clock on your forwarding engines. You're not synchronizing your clock on your computing power. So the computing power more likely will use NTP to synchronize clock, and there will be their native time format. So if you're taking timestamp in a software, in the control part, that would be your NTP, and you can save yourself conversions. Yes, conversion is trivial, but still. Another thing is that, and it's more serious, I think, it's consistency of taking timestamp. So if you are in a situation, and that's what probably will be the case for SFC, that you're taking timestamp in a software outside of your hardware, so when you already received the packet, where you're in a node experiencing unaccountable latency processing the packet, so you cannot really guarantee that you're taking the timestamp consistently. So the measurements would not be really consistent.
You mean accurately?
No, accuracy is different. Consistency is important, because the way you are taking timestamp in a control plane is impacted by latency of processing the packet in the control plane. Okay, so basically, it's very hard to characterize what exactly are you measuring. That's why when we are doing performance measurement on a path between two endpoints, there is a strong recommendation to take a timestamp on the first bit when it leaves the hardware and the first bit when it enters the hardware. So this way, you're taking the timestamp without impact of your host processing, and you're measuring delay, and then you can calculate delay variation of your path, because your timestamp is consistent, not influenced by the latency on a host. So I'm just want to be you aware that how you interpret the data is getting really hard.
So I think if I understand correctly, what you're saying is that you're looking for an accurate definition of what the time stamping point is, right?
And what you intend to measure, yes.
Okay.
Because, yes, your timestamp will influence what you're measuring.
Okay.
And another thing is that about their timestamp to help you to switch the context. 1588 V2 with the transparent clock has this transparent clock on-path support in terms of the residence time measurement. So it helps you to account for the propagation of PTP control message through the network. So I think that similar mechanism can be devised in order to avoid timestamping each packet. So you basically can run the statistics and measurement on your SFC to know what about the propagation of the packet on this path, so you don't have to do the timestamp on each packet.
So what you're saying is that we could add an additional field which is kind of computes the residence time over the path?
No, I would say that you can run just the measurement of your residence time and have it on each node, so you know that, for example, when your time to switch your context, you have their wait period, wait for outstanding packets on this flow, and they need to be treated in this way after that period. So basically, you can calculate the shift of your switch context deadline through your SFC.
Okay.
Tal, one other question that occurred to me looking at your slides. It looks like your assumption is that this would be used for packets which are not carrying any other metadata at all, because you're using MD1 and you're using the whole
Right.
16
we're talking
bytes of
about
MD1?
MD type 1.
Okay,
But, we are open to comments like, it makes sense to have a timestamp, but maybe in combination with other fields which you don't currently have. I mean, that's something we'd be happy to discuss. I mean, I think the main point in this draft is having the timestamp. The other fields are,
okay, good. We have a couple more questions. So start here.
Sumandra from F5. So one observation, I think allocating timestamp within MD1 is probably difficult for the same reason Joel was presenting. So it's probably better to have a timestamp type TLB. So if people wants to use different formats, they could use. Secondly, I was also it's not a new thing to measure service delay. So there has been already existing other works. So I was wondering why that's not sufficient for the use cases you were trying to solve. Why it has to be there. That part was not clear to me. You gave lots of applications, I understand it, but there are alternative methods to solve those things too.
right. So were you here when I presented the second slide of comparison to KPI stamping? Because I addressed exactly that issue. Because there's another draft on KPI stamping, which, like you said, also uses timestamps and allows you to measure delay over the SFs. But again, one of the main feedbacks we received was, first of all, MD type 2 is not mandatory. Not all vendors will implement it.
No, I'm not talking about using NSH at all. Let's just get back to all the users might be wanting, if I am receiving this service, I want to find out the slowest node. Let's just talk from usability. That guy is trying to debug which particular network function is actually causing a trouble for this particular user. And there is not a requirement to actually have a very fundamentally accurate measurement. It's kind of in the ballpark, right? I could use the TCP statistics also for that, regardless of NSH-based timestamp. So what I was trying to figure out, if somebody has this timestamp and somebody out in the field is actually using this, there are two questions: how the operators are going to integrate into their existing analytics tool, A, and what do I get out of it? At the end of the day, what is the extra insight they would have because of this timestamp resident in this NSH metadata?
Right. So you can use other OAM mechanisms in other layers, or the idea here was to have a timestamp in all the packets, because it's an MD type 1 allocation. That means you have it in all the packets, unless you're using MD type 2 in some of the packets.
I mean, my general observation is that if it is not absolutely requirement, I really do not like extra bits on network. So from that, on my theory based on that, it should be MD2, if it is at all.
So I believe you should probably try to convince the working group that MD type 2 should be mandatory. That
No,
would be the
I'm
first
saying
step.
this feature itself may not be mandatory, so therefore it doesn't require to be on MD1 at all.
As a proxy to the law.
No, I think there's a conversation going on there first.
Name,
Stuart Bryant. So maybe I misunderstood what you were saying, but I kind of got the impression that these were special packets going through rather than live packets. We've got many ways of instrumenting the network, but you have to measure, to be of interest, you should measure your own layer, which means you should be timing how long it takes to go through a function with live data.
So the idea was this is live data.
Okay.
Live data, and the actual measurement by the SF doesn't have to be on all the packets. It can be statistical, so that you sample just a fraction of the packets and do that measurement. But the metadata is there for all the data packets.
Okay, thank you.
Kyle LaRose, Sandvine. I haven't actually read the draft, so I might be just trolling here or something, but have you considered at all what it means for the timestamps if you reclassify or you go through a proxy? Like what do you put a new timestamp in? Do you try to maintain the old one? Any recommendations there?
That's a good point. We'll need to think about that. Right now, we're only talking about, single classifier. Once you do reclassification or proxy, we'll need to consider whether you keep the old timestamp or you timestamp again.
We probably see
For
reasons for
discussion.
both. Okay, thanks.
Thanks.
Any other questions?
Thank you, Tal.
Thanks.
Next up.
My name is Praveen, and I'll be giving a brief update on the broadband allocation draft. Jeff, Surendra, Wim, and Mohammed are my co-authors. Next slide, please. So in this draft, we define the metadata allocation for both the fixed as well as the variable type for broadband use cases. And this is in the context of both mobile and fixed broadband. Next slide, please. So in the IETF 94, we gave the presentation on how to do the metadata allocation for the fixed format. And since then, we have added actually the support of metadata type 2 for the variable format. If we look at the fixed mobile broadband use case, fixed use case, there is no extra metadata required in that use case, but for the mobile, there is a need for some more extra metadata that needs to be carried. So in order to support that, we defined a new TLV, which can be used by 3GPP to carry some extra metadata. Next slide, please. So this is the format of the new TLV. The class is defined as 3GPP, and the type 1 is actually reserved. That type 1, if you use type 1, then it refers to the fixed format what has been defined as part of metadata type 1. And this TLV will be used by 3GPP to define its own use cases as they proceed defining their flexi mobile services. Next slide, please. So the draft is there for a while, and we think that it's ready for, it's in good shape, and we request chairs to adopt this for working group document. Next question.
So what I'm hearing implicitly, and will need to be highlighted in the draft, I haven't re-examined the draft to make sure, is you want to allocate a class code to 3GPP, and then presumably in collaboration with 3GPP, you're saying, and type code 1 is the one we will, from that space, is the one we will use to carry the MD1 allocation format that we've defined.
Correct.
Which is carrying the MD1s and MD2 is something we've discussed in multiple contexts, so it seems quite sensible.
Adrian Farrell, hello. I'm not quite sure whether I'm confused about what it means. Once we allocate the class code to 3GPP, isn't everything else entirely out of scope of the IETF?
Yes, the use of one would be a advisory comment by observation based on collaboration. But the key, there is probably a procedural hurdle somewhere down the road of making sure 3GPP really wants this and will do this. But we need to, it's not a big deal for the theory, but in practice, they would actually own the definition of type 1 or any other types.
Right, and not just the definition, but the documentation.
Well, they can ask Guyana to register them for them, but that's up to them.
Right, exactly. So, having an IETF RFC that stops at the, can we please allocate a class is fine, but beyond that, what is there to adopt is my question.
We don't have to do anything beyond that. I think that will be defined by 3GPP further.
So looking at this slide, we should stop after the first bullet. Yeah?
Yes.
Right. That's good. I won't read the other bullets.
Okay.
Hi, Samandra. So this is actually not a draft. This is our, I think when we looked at NSH and we got excited, it looks like it's actually going to open up some of the things that we always wanted in service chaining and in distributed data plane environment. Now, having said that, we actually set out on to basically putting these things in practice and try to do this. And one of the things we fast ran into is this. I think this working group has done a wonderful job of data plane, somewhat forgot about the control plane. So mostly what I'm going to talk about is that when we implement it in practice, there are lots of things that we ran into that's probably not getting due credit here. And when you talk to the actual operators, those are the things that comes out as a major problem. Data plane hardly shows up a problem. Next slide. So, of course, all soup starts your own kitchen. So we started with our own functions, and we have plenty of them. So we basically started with a firewall, and being a proxy company, for us did not make any sense to actually term any node as a SFC proxy, because the proxy is sort of built in, and the last is CGNet. It could be done. What we also observed was that instead of terming a node as a SFC proxy, a attribute of a service function is good enough to tell you whether it needs to be proxied or not. If you declare a service as a SFC Anwar, that is a candidate for proxy. In fact, having an explicit proxy sometimes makes it difficult for deployment. Where should it get connected? Where it should not get connected? So in this example, like most of the video optimization or parental control type of functions are not going to be SFC ever, and probably not for quite a long time. But in existing chains in almost all operators or all, they do have these things. And when they are actually building a chain, nobody is going to basically say, I'm all going to jump in NSH or all going to jump in new thing. They're all going to say, I'm going to use the firewall, which probably gives me NSH capability, and I'm going to use the P gateway, which might give me subscriber information, so other interesting information that my firewall can use it to block a subscriber-based traffic rules. But I'm going to use the video optimizers in certain conditions when my network conditions goes down. And I do have ways to detect when network conditions is appropriate for certain video optimization. So when you wanted to do that, we have all these variations. And so how do we go about controlling this environment? So first was that any code developers, and I'm not the only developers, quite a few people wrote the code, they all asked me the question, tell me the basic minimal code I have to develop. So I have to think, okay, what is the basic minimal control point? There is a bunch of draft. I cannot give them a requirement also, is that. So next slide, please. Oh, yes, this slide, please. So one of the things that we early on found out, in academically, we can say controller and management is two different things, but when you actually try to put them in operationally, it's very difficult to separate them out. You really cannot build one without other. So I think I'm talking to a group of people who loves protocol, but it doesn't serve most of the purposes many of the times. So even though it may not be right for them, we probably could think about operationally when we actually put all these service functions together. What's the minimal control plane? What's the minimum command sets that we do need to have? So even though this is a configuration, I actually purposely put these slides because this is what we had to have in order to make anywhere. So basic configurations we needed was a service node name, few things that everybody mostly agrees, IP addresses, whether it supports SFC or not. And then we also actually had to find a new attribute called skip. Skip simply meant if this service is unavailable, you can skip it. In fact, it is very useful if you are a optimization functions. By definition, optimization is there to improve your life, but you do not depend on it. You can look at a crappy video and throw the phone out. But if you have an optimizer, you might actually keep on going with the operator. But it doesn't depend that you have to have the service. My kids probably won't like to have the parental control ever, but I would like to have. So I don't know whether that's a skip or not. And actually, that's a good question. In some cases, it might be skippable. In some countries, it may not be. So skip, we found an attribute that is actually required to be in service itself. Then came the cluster, this thing. Almost everybody, especially if you go from physical to virtual, people are clusterizing this thing. Same type of service, but not always the same VNF, meaning like even though they want to have the consistent VNF providing the service, in theory it doesn't happen. Why? Because when you create a chain, oftentimes they roll in as a rolling upgrade. Certain things, certain infrastructures get upgraded, certain infrastructure hasn't got upgraded. So you generally have a non-consistent pool. What it means is that what we found that is a criteria to select a service is quite important. You cannot really spew the flows around and expect to have a very consistent and optimal behavior. That doesn't really occur in practice. So in the service cluster, having a selection criteria is a good thing. That's also became part of the configuration. SFF was the easiest to configure. It basically required, well, it's IP, this is where I'm connected, done. And finally, the chain. Chain was ordered, and all we need to have a chain, whether it's symmetric or not. And as I said earlier, we actually didn't have to say it's a proxy or not, because the service definition told us whether I need to proxy or not. And simply proxy meant our case that almost anybody could be a proxy. It simply means it has to have a lot of memory because it has to generally push and pop lots of states around. Save the NSH context in one end and restore the NSH context already. Next slide, please. So service chain types are fairly simple. This is symmetric. We also have a asymmetric. Asymmetric chain means that you generally have to have a classifier on the other side of the thing. It kind of felt unnatural, and anybody has any example as asymmetric chain? I would really love to have an actual practical example. We kept talking and didn't find one. So, okay, great. Love to hear from you. And then the skip. So the symmetric chain looks the simplest. It is simple because the way you come, you go back. Except it becomes quite complicated when you have a chain of or pools are chained. Why? Because in one case, you might be hitting on the ingress path, instance number 4, on the reverse path. If you are looking up based on purely on path ID, you are not guaranteed to get instance number 4. If the path actually, if the service function cluster is represented as one service function. What does it mean? That means we have to have some other keys, flow keys or whichever keys are appropriate. In certain devices, it's easy. Certain devices, it's not easy. In our case, because we are a flow-hour device, looking at the flow is the first thing we do. So it was not a big deal for us. So for us, the building the symmetric key chain was quite easy. But we did realize if we actually make it a packetized system, it actually might become a little more complicated. Next one, please. So what do we ask from this thing? So so what we found is that this is really what I'm asking this group to consider, and hopefully we can get to a consistent behavior, is that the number one we found that I have to somehow configure the forwarding table to this SFF. Lo and behold, there is no standard method for that. We know how to do our stuff, so we wrote a bunch of REST APIs that other people can call and control. And I started looking around what other REST APIs I do have. So there are a couple of ways to go it. I could go ahead and write plugins in various ODL or some, but that's not the way to really go. And if we actually think a standard forwarding plane is there, we should also have a somewhat of a standardized, agreed upon way to actually, I'm saying I'm not worried about how you implement the forwarding table, but how do I program your forwarding table so that I can give the meaning, which is really the association of path to the next hop, as simple as that. How you actually implement in your hardware software, we don't care. And some attributes also. The second thing was that if we have multiple types of SFF, it would be great to know what that SFF actually is capable of supporting. Is it a dumb one that can only look at the packet? Does it have some idea about how to distribute packets? And if it's so, hash-based or whatnot. So when a controller actually gets this capability, it's easier to actually program the chain And sometimes the orchestrator would be smart enough to figure out this SFF is not the right spot for this kind of service function at all. And that is something is also we found is very requirement. So these two are the things we kind of like came out with. This may be the base of a minimal control plane or controller sort of thing, that if we actually have access to those informations, then everybody can go out and sort of build it out of that. Next slide, please.
Oh,
go ahead.
Greg Mirsky, ZT. In the previous slide, so you reference hash. What hash specific information are you looking for? Number of fan out or hash algorithm characterization?
Algorithm characterizations. For example, if it says I can do consistent hash, then I know for certain type of services, we can actually put this service up there. If it says that it can only do source IP port hash, then certain types of, if, for example, if a L7 device basically says that they are capable of doing consistent hash based on URI, I know I can put a transparent cache on there. I cannot put a transparent cache effectively on the device which only does port IP hashing.
Okay, just continue this. If there are multiple capabilities, okay, so does that mean that then next you would like to tell him which one to use?
No.
You sure?
Which SFF to use?
No, which of hashing algorithms to use. So if you receive that there are multiple available,
yes.
You want to tell me, oh, you use for this?
Yes, yes. In fact, actually, I think in the minimal configuration, we also said, if I define a cluster, tell me what type of selection algorithm to use.
Okay.
Because that we really like to know. We don't want to make a guess on it. No, absolutely not. That's why it's a part of one of the minimal requirement configuration. Yes. So the other thing we thought, okay, not everybody is going to have a load balancer every. In fact, it's not a recommended way of doing things anyway. It's actually will push your cost up. So can I basically do a central selection at one time? So there is a couple of ways to select. Select at every hop, which has its certain advantages. It is good for distributed design. It has some other disadvantages too. Or I can actually select a path early upfront in the classifier and make sure the packet goes through that. That also has some advantages. Then my SFFs can be quite dumb. Okay. So going forward, we said, okay, how do we go about it? If it is a singleton, no issues. A path defines exactly the path, exactly the sort of the couple of VLANs I need to. If it is a service, is a clusterized service, then maybe I could do every path is a sort of the full graph of the whole thing. Well, that's where we run into scalability issues. Like it's a order of n problem. It's just that the longer the chain becomes, the number of paths becomes a lot more. I was really happy the path is 24 bits, but in that case, the 24 bits also not sufficient. The other observation we hit was the 24-bit is actually way too much. In fact, we don't want to use 24-bit for path. We should probably ask working group, let's have some kind of a mask definition that controller can push it to the SFF is that other bits, please don't look at it. This is my garbage and I know what to deal with it. Use this as your table lookup keys, not the whole bit. In fact, we are using like some of the bits to say whether it's reverse path, whether it's this type of path, whether it's that type of path, all kinds of things. What we actually found interesting solution, and this is, by the way, I mean, this is not there are operators out in France who are actually using this similar thing, which is basically a chain of things. So instead of if cluster, if I vertically, instead of just selecting at every vertical SF and then going to the next service and selecting independently, we could actually cut them in slices, and then the slices can be represented as a path because my numbers are based on however many are there in N. So, and I have plenty enough bits in that to support. In that case, what we found is actually it's pretty easier to support a central selection of the path early up and then follow it, and even have the skip available in case B is a optimizer and you want to jump on it. So in that case, path sort of becomes, it's a number, slice number and the path ID, but you can look at that way. But to a forwarder entity, it will look just like a path ID. Next thing, please. So this is where we are actually coming. So at the end of the day, the realization was a data path, great. But adoption is not going to happen until we cross this bridge. It's basically a protocol that's most likely will not succeed unless we solve the control plane side of the things. That thing has to marry down so that actually people can use it. And in order to use it, we actually need to sit down and come up with a minimum set of APIs. And I really don't care whether it's we come up with a schema definition in JSON or somebody proposes that OpenFlow commands is actually good enough and we standardize on that, but we need to have that debate. We need to have a debate about how do you do the capability exchange. And then we can have many good to have it, but I would love to start with the must-have set of the things that actually supports everybody.
Name?
Kyle Rose, Sandvine. I found this quite interesting. I worked on defining the data model for Sandvine service function chaining solution, and we came to a lot of the same conclusions. Particularly the skip one was quite interesting because I was struggling with that, and I'm like, well, why don't you just skip it? You know, and then but we're like, well, maybe some people don't want to skip it, so make it configurable. And so that was pretty interesting to see. You mentioned that. Why do you say we shouldn't worry about the classification rules of the controller?
Oh, good question. Actually, we looked at that. Do I have to have a controller that needs to have the classification rule? Two things. In mobile operators, they all told that I get my classification rules from PCRF. Okay, fine. Ask others, they have some model for classification rules that they want to. So what it looked like, yes, in a workflow, it is required. But again, for a minimal building service chain, all we really required classification rule to a path ID mapping, not the definition of classification rule. As long as I have the mapping, we are done. So that's what I meant by that. That was what was the comment about. But what we could not avoid, if we put a Cisco device in between or something between, we have no idea how to program his forwarding table. And that's where we are kind of, okay, we're coming back to that point where we do need a consistent API or something where we can control others.
Did you find any place for metadata in this at all, or was that, again, it's not part of the minimal set, so you sort of just let that?
No, metadata?
Like the NSH metadata.
You're talking about metadata, right?
Yes.
Okay. Any use? Oh, yes, plenty. I think one of the side benefits of NSH in mobile case is that you can actually put a lot of the metadata in the NSH and remove some of the GX endpoints, which would actually be a good thing.
But I guess from the perspective of this presentation, though, would that then be, I guess, part of the classifier, so not kind of out of scope?
Oh, no. That could be part of the scope. Again, for what we basically want to, in fact, that's a good point. That could be a part of the scope, yes. What metadata to put in, yeah. Yep. We solved it because we have a scripting language. We kind of solved it that way. Maybe it's a part of configuration at all. Write your own script that will get fired on a given flow that will put the metadata you want. But yes, in fact, the code is the configuration in that case.
Thanks.
Right-hand mic, and then we'll come back to it.
Pedro Pedro Martinez from the NNCT Japan. Well, I just want to mention that from my point of view, the skip mechanism is actually not a good idea, because from the simplicity point of view, if it is not needed, if such function is not needed, just skip it from the beginning. And if it is required, you cannot build the chain without it. So having this kind of way of, if it would be better to have it inside included, but if not available, well, yeah, don't worry. No, I think it's not good, especially in this sense, because you are not building one chain for one long-term system. You are building the chains dynamically. So if it cannot be done, just reject it, and then the management system will choose another thing.
So-
another option. Yeah.
Okay, so I'll give you two answers.
Yeah.
A, the skip is not required. B, skip is not required. It's a good to have. And actually, I'm fine that if we get agreement on how to program the forwarding table, forget. I don't want skip thing at all here. We can keep doing. Secondly, I would actually contest your assertion, manage it dynamically. Now, when I actually talk to the operators and people who put these things in practice, they are way behind. They're not that dynamic. I don't know how many operators. I get a different vibe. We think in this room that things can be pressed and done. It's not, for a couple of reasons. Everybody comes and says that you could do the program, but when you look at the number of REST API calls that goes from controller to this thing, that sucks. And I agree, that sucks. We started with that, and we ended up doing a totally different model, informal performance thing. So that's what I'm saying. Like when we actually try to meet as an operation model, some of these things doesn't fan out. To give you an example, in order to configure a service chain, let's say you have n API calls. You lengthen the chains, n multiplied by n, multiplied by many of the RTTs that these systems can have, you might not be building a dynamic chain that dynamically anymore.
Yeah, so in that case, what sense does it have? If you had to build it by hand?
No, I'm not saying hand. What I'm saying is that it's not as dynamic as you are thinking. Is that if a operational guy sees my video optimizer is loaded, and now I'm going to build a chain, a alternate chain that doesn't have, it is actually easier to skip over than build the alternate chain and put in. That's in practice has been proven true.
Yeah, but what I mean is that in practice, from actually even from the implementation point of view, I find it easier to just let the system say reject one chain and say because I cannot meet with these requirements, because I don't have this function. Yeah, and then the manager, being whatever, can decide what to do.
Yeah.
Instead of implementing in all the orchestration part, implementing that, well, this function can be skipped, so we have to check if it is available. And what happens if it is available now, but then in 5 minutes it isn't, or something like that.
Yeah. Yeah.
Or even what happens if I am programming change and I say, well, all functions will be skippable. What I mean, no? Unless the first or the apart from the first and the one, all in the middle are skipped, because it will be easier in the future. Or say, instead of thinking if it is what I mean, sorry, if it is mandatory or not, just I don't think about it and just skip.
So my vendor answer, I can give you two answers: engineer answer, vendor answer. My vendor answer is sure, go ahead, whatever you want to do. Okay. We give you the APIs, right? It's a loaded gun, shoot at it, any direction you want. My engineering answer would be, you might not find it as dynamic. I'll tell you why. The number of API calls, go and count how many API calls you need to build a chain versus a flow gets redirected over is much simpler. Always.
Yeah. From the API point of view, but from the implementation, if you are implementing the chain itself, the internal part is more complex, and it's complexity just in the point where you want simplicity. You don't mind about complexity in the management part.
Yeah.
You need to reduce complexity in the implementation part. And this, from my point of view, the skip mechanism moves complexity from the management part side to the implementation.
Okay.
Can I interject?
Sure.
Kyle from Sandvine. So, imagine you have a bunch of flows going through a service function, say a video optimizer, and that video optimizer crashes. What do? If it takes you a second, 10 seconds to reprogram all of your service function paths across all of the different devices to skip that or to go somewhere else, or if you've run out of, you can't load balance away from it anymore, you just drop all flows for 10 seconds. Do you know how many calls your NOC is going to field because of that?
Yeah, but that would be part of the management plane or control plane in this case.
No, but I think the point here is that the management plane actually won't be able to keep up with redirecting all this traffic dynamically. You need data plane redirection.
Excuse me, this sounds like something where we need an explanation in writing in an internet track.
Maybe.
Trying to sort it out from what I'm hearing from different people, I can't tell. I'm guessing other people can't tell. So We have the problem that this particular proposal does not yet have an internet draft. And
No.
this is the kind of thing drafts really help us understand is
Yes.
what case do you try to solve here?
So,
Yeah, so
That's okay.
Samandra, the other point I would make that would be really nice is to, in that definition of skipping, we already have the offload functionality that we've been looking at. So how does that differ to that? I think I understand in my head how that differs, but it would be good to kind of make that
Can you move
clear
to the
as
last
well.
slide, which basically says,
Okay.
which really asks this question. So do you guys like to see a sort of a draft of minimal control plan, what we think? And then is something people will be interested? Okay.
The working group will decide if it's of interest when they can see a draft, but people are allowed to ask more questions, and we have 2 people in the queue.
Okay.
Well, too, Intel risking sounding like a broken record. I think the question is, what does this work group want to do in order to really make NSH as an implementation of SFC useful in the industry? I think you're shedding light on some of the issues, but let's say the work group addresses everything you said. I don't know that is enough. So the question to the chairs is, what tools do we have in order to enable broad industry deployment? I think the presence in the room 3 years into the action suggests that there is high interest in the industry to see this working. We have invested in data plane. I think Sumandra used the example of a PCRF, which I also believe is an interesting, viable option. While there is room for innovation for folks, I think maybe we could do something as a liaison, something as working with some open source consortiums in order to actually create some minimal, what you call minimal controller, I'd like to call minimal implementation that simply shows the path. How we go from some policy that comes out of a PCRF and we end up in the data plane, then I think we take off. Before that, we are the plumbers building something, and would they come?
So my question is also to the chairs. I think we kind of felt in the same way as that we have done half of it, but unless we finish the other half, it's not going to take off. That's really, I sort of agree with what he's saying. Yes.
Adrian Farrell. So I think this is a useful starting point for discussion. I'm not sure how much of this might end up as an RFC, but that's not the point of seeding the discussion. So a draft would be really helpful for that.
Okay.
And I think there's a separation that it would be nice to make between the title of this slide, which is minimal controller requirement, which is very distinct from minimal control requirement.
Oh, yes,
yeah?
yes.
And so I particularly like this title. The control, in other words, the control and management plane piece of it is horses for courses. So if you've got a fairly simple chain in a fairly simple network, then a centralized controller with a kind of north-south thing makes a lot of sense to me. But if you've got a much more complex network, then I'd like to do the advert for our BGP document, which has just been adopted by the BEST working group and posted there. And you guys in this room need to be looking at that and feeding that, whether we are meeting requirements, we've missed bits, we've over-engineered or whatever.
Yes, I actually read the draft over the flight, and I was seeing that this draft is trying to address the very similar things that we are trying to address in a different mechanism for a different use case. So it does make sense that we do have some sort of a minimal definitions and then methods to achieve that minimal definitions. Yes, I do agree with that.
Okay.
And there's the PCE draft, which is also addressing parts of this that are relevant to this discussion and other proposals other people have. And that's one of the issues we as a working group have to deal with. Lucius. There are people who need to sign them. If you haven't signed them, please do. And at that point, the next topic on the agenda, and we're very slightly behind our planned schedule, but only slightly, was open mic for discussions of topic of interest to the working group. What things do you think we don't know enough about, we need to discuss, what you would like to hear from other people in the room about? Some people have mentioned to me, what about OAM identification? Can we close the TTL discussion? I don't know what you guys want to talk about. What issues do you think are open that matter to you? I lost count of how many times I sent messages to the list. And I'm sorry, speak a little slowly because it's important for the minute takers to capture this stuff.
Kyle LaRose, Sandvine. I'd really like to close the TTL discussion. So.
And would you like us to use the TTL that has been proposed on the list or something else?
Yes, I'm in favor of the TTL.
Okay. Anybody else want to comment on that one? Rough consensus obviously is actually on the list, but we have been observing the list, and I will say that from my personal perspective, what you've just said is consistent with what I think the rough consensus on the list is. But we haven't reviewed carefully to say, did we miss any important emails or anything?
Another topic that was discussed
Your name, because we got another
Tal
minute.
Mizrahi, sorry about that. Another topic that was discussed a couple of months ago on the interim was making MD type 2 with length 0 mandatory. And I think there was rough consensus about that at the time. So I wanted to ask whether we're ready to add that, to incorporate that into the draft.
Good question. Anybody comment? This was brought to mentioned in the minutes. It wasn't highlighted as a major issue, but it probably is a bit more major than we called attention to, which is to say, in addition to making MD type 1 mandatory, saying that for SFFs, MD type 2 with a 0 length was mandatory to support.
Right.
Seems to make sense. Again, simple thing to do, handles clean cases. And if that gets in the minutes, it will help us to track to make sure we do follow up. Anything else?
What did we have on our list? Maybe we can do some prompting here because I have a pretty long list.
Yeah, so the next one, I believe we have called agreement on, was the CBET. Right? We're getting, that was, I believe, called to an agreement on the mailing list that the CBIT is going from the NSH header and going from the type codes. We're not going to have something marked critical. Now that has implications for OAM. We have text on what OAM means, and that text isn't affected by this change, but it may be that your thought process about OAM is affected by this change. As far as I know, we've still got the current text as the agreed OAM text, with the O-bit retained with its meaning as described in the current draft. Some folks have expressed some concern about this, but I didn't see a rough consensus to change it. But if somebody wants to bring it up more, okay.
One of the things, if you haven't done it already, that I'd encourage you to do is to go and read the interim minutes. There was actually a lot of topics and detail covered over the 2-day interim meeting that we had. We captured probably, 20 or 30 action items across a whole bunch of different things, and a lot of different topics were discussed. And what Joel and I have been doing is trying to chunter our way through at least the action items on the NSH document so we can get that closed and moved on so we can focus more time on other topics. I think from my read, the TTL was probably the last open item from that list. Most of the other ones we've done the consensus on, and I know the editors of the document have been busy trying to keep up with those edits to NSH, and there should be another version coming out too. But we definitely want to close on that TTL discussion. We can't do that today, but I encourage that we'll try and get that done on the mailing list and then move that document forward. So again, go and look at the things that were discussed on the interim if you haven't already done so. And if you have comments on any of those things, then use the mailing list. Let's try and tie a lot of these loose ends off. I think from the chair's perspective, we're as anxious to move on as everybody else is, and but we need help from the community to do that, and hence this Q&A session here, that we want to make sure that we push the working group in the right direction, covering the things that you care about. We asked Samandra to presentation to look at it from the implementer perspective, and I think that was really good feedback. We should talk about how do we. I don't want to go away from here and be having this same conversation again in Prague. I want to see something actually happen between now and then. So let's, get together and make something happen. So if that means that it needs to be a draft that talks about those minimal requirements that we need, let's get that done, because we had a lot of discussion on the control plane requirements document, and at least for me, it was pretty clear that we don't really know what to do with it. So let's get more eyes on these things, and doing my pitch to get you guys involved, and let's try and move some of this along. So what did we have on our list? There were a couple of things. The NSH was one, and then what do you want me? Okay. So one of the things that Joel and I have been doing in the background is look at some of the feedback that we had from the interim. Was there were a lot of people anxious to move the metadata aspects forward, and we came to some conclusions at the interim that we documented in those minutes. One of which was we felt that we should go ahead and try and adopt some of the Type 1 documents and get more eyes on it and start working through those. So one of the actions was to document that in the minutes, and if there's no objection, then we'll start that kind of adoption for the Type 1 documents. The second was that we wanted to move the Type 2 discussion forward as well, and there was a lot of discussion around where should the TLVs be documented. Should they be in their own documents, or should we have one big honking document that has the TLVs? We kind of came to a conclusion that it was useful, we thought anyway, to have a document that was able to list a set of TLVs that could be described in a very short manner, a sentence or two, and if it was anything other than that and it required a longer explanation, then we would put those into specific documents, and also use the TLV2 document to get everything clear in terms of what registry we needed, and so forth. So there was a lot of discussion on that, a lot of text to go in there. I think it was, so we we look to get a new editor for the TLV document to actually have somebody that has the time to, or some time to work on that. We asked Samandra and he very kindly agreed to do that. So that's another document that I think we're going to call for adoption into the working group so we can actually start making some progress on the TLVs. Anything else you want to say on it?
So in that, along the lines we described in the minutes from the interim and that people saw in discussions on the mailing list, the idea is that that will define things which do not need long descriptions and which are not for any other reason captured in some other document, but not simply recapitulate and attempt to reassign something somebody else does the job for. So there'll be a bunch of things in there, and then, but it's not the only document for assigning code points out of our type space. We can use other internet drafts that become RFCs to do the same thing. For example, some of the Med was very interested in just keeping his application ID draft, and because he has a lot of explanatory text there, so okay, that goes forward. It's a companion to the TLV document. And similarly, if there's an MD1, if we have MD1 documents, now the one that was presented may be a little different, but if we have MD1 documents, well, then we're going to define them, and we can define in that document an MD2 code point for carrying the 16 bytes of content that is described there. We don't need to say somewhere else. And the number for carrying that thing described over there is this. You can do that where you define it. No need to repeat things. But there's lots of things that are useful to put in, and we very much appreciate that Samandra is going to take that forward. The other thing is we're looking at moving the OAM document forward, and we're trying to figure out how to get the OAM framework document unstuck so that there's a good place to put all the OAM issues that are specific to this. Note that NV03 is doing a lot of the overlay OAM stuff that is general, that applies to a lot of other contexts, and we will be collaborating with that. And the IPPM is starting to work on in-band OAM, and we will collaborate with them. I was told that they might end up throwing it back to us for the SFC usage, in which case we're happy to work with it here, but we're not going to say, we must own it just because we must. We'll work with other working groups and other chairs to carry work forward as appropriate. Just as we're working with Bess on the BGP control plane, and we'll work with the PCE guys on the PCE control work. We're collaborating with other people to make things work for the IETF. Oh, there's one other work item that I see in the minutes from the interim. Do we need a separate security document? There was some discussion on the list. The interim seemed to conclude that it wasn't doing us any good. We didn't hear much conversation indicating support for the document, but so we're probably killing it. But if somebody feels we need one, they need to speak up, probably on the list.
So any more burning issues that people want to raise? Carlos.
Thank you. Carlos Pignataro, Cisco. Since we have time, I did want to bring up one issue to the awareness of the working group, which is part of the work in the in situ OAM or IOAM. IOAM is a body of work that we presented in various working groups for the last 2 IETFs. Many of the actual use cases that we have, for which we have running code, are targeting SFC applications, including NSH in particular. During this, what I wanted to do right now is essentially 2 things: give a 2-minute update of what happened and where things stand, and second, a request to the working group. So what happened during this IETF is that we actually brought that piece of work to IPPM, to the IP Performance Metrics Working Group. In particular, we're targeting the adoption of the data structures document in IPPM. There seems to be good support for that. So, there is a decent likelihood that that's what's going to happen, that the data work is going to live in IPPM. We want low overhead. We don't want a lot of requirements, documents, and use cases, etc. And then the transports probably are going to happen within different working groups. That means that, we're going to come back to SFC saying, hey, we need this set of NSH code points for IOAM. And we're going to come back with one more thing, which is one of the drafts, which is proof of transit, is about, as the name implies, proof of transit during a service function chain. And that one is a use of IOAM, which targets specifically NSH and SFC. And that is a document that, when is the appropriate time, and I think it's a little bit early right now, but when is the appropriate time and the data matures a little bit more and has a home and has a working group, we're going to come back to SFC to, request potential adoption, and really not only adoption, we really want review. We really want feedback. We got very useful feedback on some security considerations on the proof of transit when we present it in the last IETF, as well as in the previous IETF. So that's been immensely useful. We want to continue that, and potentially midterm, request for SFC to be a home for the proof of transit. So with that, any comments, questions, observations about IOAM, more than welcome. Thank you.
Not seeing anybody approaching the microphone, I guess we'll give you back the rest of your time. We need the other blue sheet, please.
Okay, thank you. Yeah, if anybody hasn't signed this, please come up and do so. Yeah.